Hi guys! Welcome back sa ating channel. So, kumusta kayo? Medyo matagal tayong nawala. Medyo matagal tayo din nakapag-upload ng videos. Kasi busy tayo sa online sabo. So, pag-usapan natin sa video natin sa projectile motion or motion of a projectile. So, the pre-flight motion of a projectile is often studied in terms of rectangular components. To illustrate the kinematic analysis, consider a projectile launch at point x sub o and y sub o or y sub 0 with an initial velocity v sub o having components vo sub x and vo sub y, where yung vx at saka yung y nila is a vertical component at horizontal component ng ating velocity. When air resistance is neglected, so nililiglig yung air friction, the only force acting on the projectile is its weight. Siyempre yung weight ng object, which causes the projectile to have a constant downward acceleration approximately. So yung acceleration is the gravitational acceleration, which is 9.81 meter per second squared in metric unit, or kung English unit naman is 32.2 feet per second. So this is the expression. Meron tayong xy plane, x-axis and y-axis. So this is the projectile motion and this is the angle of the motion. This this is the point x sub o, y sub o. This is the initial velocity v sub o. So initial velocity, since wala siya sa x and y axis, x or y axis, meron siya dalawang components where yung v sub x, vo sub x, which is yung horizontal component niya, and vy, voy, which is yung vertical component niya. So makakabuo tayo ng rectangular, binubuo ng dalawang components. Then this is the final velocity or final point. So initial point at final point ng ating projectile. So this is the final velocity and meron din yung horizontal and vertical components, Bs and By. Makakabuo tayo ng isang rectangle dyan. So yun yung projectile motion natin. So then, this is the y sub o and x sub o. This is the y and x distance. Yun yung mga coordinates ng ating points, initial points at final points. And this, yung ating downward acceleration is the gravitational acceleration, 81 meter per second squared or 22.2 meter per second squared. So this is the highest point ng ating curve or ng ating projectile. In this, sabihin yung ating y maximum or the highest range ng ating projectile. Kaya yun ang illustration. So dito, mabubuo tayo ng isang right triangle, di ba? So using trigonometry, so kasi this angle theta, automatic, this angle theta rin. Tama? Yung angle dito, tsaka ito is equal. So cosine function is equals to cosine theta is equals to horizontal component over hypotenuse, so yung v sub o. So rearrange Box. So horizontal component is Bo cosine theta. Kung cosine yung ating horizontal, so automatic yung ating vertical is sine function. Sine is equals to opposite, where yung opposite angle, opposite side is Boy over hypotenuse ng ating triangle is Bo, v sub o. So Boy is equals to Bo sine theta. So yun yung kailangan natin compute muna kapag yung ating initial velocity is wala sa x axis and y axis. So compute natin yung dalawang components niya. Okay? So ito yung mga formulas. So recall natin yung formula sa previous video natin, which is yung uniform acceleration or acceleration is constant. Ito po yung mga formula natin. S equals to initial velocity times time plus 1/2 acceleration times squared. And final velocity squared is equals to initial velocity squared plus 2as. And final velocity is equals to initial velocity plus acceleration times time. So dito manggagaling maging formula natin sa projectile. So kasi dito meron tayong one axis lang, horizontal axis. So kasi dito sa projectile meron tayong horizontal axis at vertical axis or horizontal projection of motion at saka vertical projection. So sa horizontal, since wala tayong acceleration, so cancel to sa horizontal. So matitira dyan velocity times time, yung x distance. Dito wala rin acceleration, so dito wala. Matanggalan ang acceleration sa horizontal projection. So matitira ang formula natin dyan sa horizontal projection distance x is equals to initial velocity along x times total time. Sa vertical projection naman, so dito marami vertical projection of motion, so meron tayo yung acceleration, which is yung gravitational acceleration natin. So yan, yung s magiging y by distance is equals to initial velocity along y times time minus 1 half. Bakit minus? Since yung ating gravity is downward, so minus g, so nilagyan na natin sa unahan. Yung plus, naging minus na, so 1 half g squared. So pwede nyo rito gamitin. So huwag nyo lang kakalimutan na nalagyan ng negative yung 9.81 or 32.2 yung gravitational acceleration. So dito nilagay ko na ng negative. O pwede rin, v, final velocity along y squared, final is equals to initial velocity squared minus 2gy. So pwede rin yan. So s, pinalitan natin ng y. So then yung a, pinalitan natin ng g. So pwede rin final velocity along y is equals to oops. So type po, y po to y. Yung. Is equals to initial velocity along y minus gt. So yun po yung mga formula natin. Meron din tayo mga special derived formulas where na-derive lang rin yan dyan sa ating mga formulas. So shortcut ito, mga derived formulas. Hindi ko na pa nakikita yung derivation kasi medyo mahaba. So negative is equal, y is equals to x tangent theta minus dx squared over 2 initial velocity squared cosine theta squared. So yun yung formula para makapit natin yung y distance ng ating projectile. Kung gusto nyo makapit yung y max, so initial velocity squared sine squared theta over 2g. Pero kung ayaw nyo naman ito i-memorize, so makakompute nyo rin yung sagot gamit itong mga formula natin. So yan. Pero kung trip nyo mag-memorize, pwede ito. Shortcut. So note, to attain the maximum range. To attain the maximum possible range, a projectile must be fired through an angle of 45 degrees. So tanda po natin yun ha. So kapag hinihingi yung maximum range, na tulang given take angle, or kahit may given yung angle, so hinihingi yung maximum range, possible maximum range ng ating projectile, so dapat yung angle natin is naka 45 degrees. Okay, yun lang yung formula dyan sa ating projectile. Proceed na tayo sa sample problems. So problem 1, a sack slides off the ramp shown in the figure with horizontal
Kayo na ako mausap dito ha. Nakakapikon to, hindi ko maintindihan eh ha.
velocity of 12 meter per second. If the height of the ramp is 6 meter from the floor, determine the time needed for the sack to strike the floor and the range r where sacks begin to pile up. So ito yung figure natin. So meron tayong sako, nag-slide dito sa natin. So syempre meron tayong initial velocity na 12 meters per 12 meter per second. Where yung velocity natin is along x. So yung ating initial velocity along y is 0. So ang hinihingi sa atin is total time. Ilang seconds daw simula dito hanggang dito. So, and the range r. Ito yung distance nito, initial point to final point. Ito yung distance r. Okay? Solution. So yung figure natin, nilagay ko dyan. So, itigan muna natin yung mga given. So, since ang ating unit is metric, so ang ating gravitational acceleration is 9.81 meter per second squared. So, binigay na yung ating initial velocity along x is 12 meter per second. Initial velocity along y is 0. Kasi wala naman tayong velocity along y. Gets ba?
Gulo-gulo!
Pero kung ang motion ng ating projectile is pag ganito, automatic meron tayong horizontal component at vertical component. Eh kaso, wala tayong hindi ganun yung motion natin. So, along x yung ating 12 meter per second. So, yung formula, lagay ko na dyan. Para pipili na lang tayo dyan kung ano mas magandang gamitin. So, vertical projection of motion. So, ito pa yung mga formula natin. Since, dito sa tatlo, pwede natin gamitin ito. Pero ito hindi pwede. So, pwede rin. Kaso wala tayong final velocity where yung final velocity is velocity at this point. Meron tayong initial, makapit natin yung y. Pero wala pa tayong velocity at point B. So, pwede sana kaso medyo matrabaho pa. Then ito, so ang kumpitin natin is time. So, wala rin tayong final velocity. So, wala rin to. So, ito ang pinakamadaling solution. So y is equals to initial velocity along y, t minus 1 half gt squared. So along y is 0 yan. Diba? Wala na to. So maging is y is pababa, so negative 6. So nandito yung initial natin. Kumbaga sa Cartesian plane natin, ito yung initial point. Then nandito yung ating final point sa 6. So negative 6. Tama ba? So negative 6 minus 1 half gt squared. Okay ba? Nag-guess nyo kayo negative 6 na. So, magiging sagot niya natin is, cancel yung negative sign, so magiging time is 1.106 seconds. So, ganun lang. Pipili ka lang kayo ng mas madaling formula para makumpit natin yung unknowns. Since dito, pwede rin naman ito, pero matrabaho pa, kumpitin nyo muna yung final velocity. So, ito na tayo, mas madali. So, then, kumpit natin yung R. So, meron na tayong time, so along na tayo. Horizontal projection. So, ito pala yung formula. So, mapansin nyo, ito yung h. So, 1 half gt squared. So, ito po yung formula ng free falling body. Height ng free falling body. So, since yung ating velocity is walang velocity along y-axis. So, parang nahulog lang yung sack, parang nahulog lang. So, walang initial velocity. Ito po yung formula. So, imagine niyo kapag naghulog kayo ng barya, sa taas kayo ng building, naghulog kayo ng barya. So, kumpitin niyo yung height ng building. So, kailangan nyo lang yung total time kung kailan nag-touch sa ground yung ating points. So, assuming na sa ganitong formula is ninineglect yung air resistance. Okay, yung wala yung air friction. Okay, ito yung formula. So, horizontal projection of motion. So, meron tayo initial velocity na 12. So, para makumpit yung R is velocity times time. Is yung X is yung R. Initial velocity natin is 12 times time na 1.106. So, that will be 13.272 meters. Gets ba? So, ganun lang sa projectile. So, try pa tayo ng isang problem. So, the chipping machine is designed to eject wood chips at the initial velocity 25 feet per second. So, since ito yung naka-fit, so naka-English unit tayo ha. As shown in the figure, if the tube is oriented 30 degrees from the horizontal, determine how high, or yung h, the chips strike the pile if at this instant they land on the pile 20 feet from the tube. So, drawing natin yung figure. Ito yung figure. So, meron na tayong, ito yung chipping machine. So, doon nilalagay yung wood. So, siyempre, pag na-chip na yung ating woods, so dito yung dadasek. So, magkaka-form siya ng isang projectile motion. So, ang hinihingi sa atin is yung height nito, which is yung h. Okay? Then, meron tayong initial velocity ng 25 feet per second. So, kailangan natin makompute yung kanyang horizontal component at saka vertical component. So, ito ay using trigonometry. Ito ay 25 cosine 30 and this 25 sine 30. Okay? Kasi tayo sa solution. Ito yung figure, nilagay ko na dyan. So, lagay mo natin yung mga given, which is yung gravitational acceleration is 32.2 feet per second squared. Yun. Yung initial velocity along x is 25 cosine theta. So, trigonometric function. So, magiging 21.65 meter per second along x. And y naman is 25 sine 30 is 12.5 meter per second. So, pag solve natin yung mga given, ito yung mga formula na pwede natin gamitin. Pipili lang tayo dyan. So, alamin muna natin yung hinahanap. Since ito yung h, di ba? Ito yung h. Pero ang hinahanap sa atin is yung distance daw. Ang kailangan natin muna kumpitin dyan is yung difference in elevation nito. Yung top ng pile at saka nitong point O. Kumbaga, O to A. So, it is distance. Intindihan niyo ba? Itong distance na ito kailangan natin kumpitin sa y. Say y. Ibig sabihin, h ito, di ba? Plus y is equals to 4. Given niyo yung height daw nito hanggang sa ground is 4 feet. Ibig sabihin, h is equals to 4 minus y. Yung 4, bawasan natin nung makumpit natin na y. That will be the final answer, h. Intindihan niyo ba?
Gulo-gulo!
So, kumpitin muna natin yung y. So, sa horizontal projection, makukumpit natin yung time. Kasi meron tayong distance 20 feet. Di ba? So, R is equals to velocity along x times time. So 20 yung ating range is equals to yung kanyang initial velocity along x, 21.65. Makakompute natin yung time. Total time from point O to point A is 0.924 seconds. So wala pang 1 second. Ay, 0.924 seconds. Kung nakompute natin yung time, so makakompute na natin yung vertical distance y. Gamit yung vertical projection, pwede natin itong gamitin. So again, pwede rin ito at saka ito. Kaso nga wala tayong velocity at this point. So kailangan pa natin yung kumpitin. Medyo matrabaho pa. So dito tayo sa mas madaling solution. So initial velocity is y. So since yung ating y is pababa na naman, so negative y. Initial velocity y is 12.5 times time na nakompute natin. 1 half g t squared. So negative y. 12.5 is yung time na nakompute natin. Gravitational acceleration times squared. So, makumpute natin y is 2.196 feet. So, subtract lang natin to sa 4 feet na given. So, makumpute natin yung height nito. Okay ba? So, 4 minus 2.196, this will be 1.804 feet. So, that's it. Ganun lang po sa projectile motion. Kaya may niwan ako dito problem for practice. So, a projectile is fired from the roof of a building 150 meter high with an initial velocity of 150 meter per second as shown. Neglecting air resistance, find. So, ito po yung ating figure. So, meron doon sa top down ng building. So, yung height ng building is 150 feet, ay 150 meters. Yung initial velocity is 150 meter per second. So, kailangan nyo dyan computin is yung kanyang horizontal component at vertical component. Since meron tayong slope na 3:4, so, ang kanyang horizontal component is, ang kanyang vertical component is 3/5 ng 150. Tapos, ang horizontal component niya is 4/5. Yeah, given yung slope eh. So, pinapakumpit sa atin is the horizontal distance from the gun to the point where the projectile strikes the ground. Yung maximum range, yung R, X, yan yung X max. Then yung number 2 point natin is elevation above the ground reached by the projectile. So, hiningi sa atin is yung Y max. Pwede nyo gamitin yung derived formula o pwede nyo rin gamitin yung discarte natin na yung horizontal projection at vertical projection. Doon sa number 1, yung pinapakompute is yung maximum R. Dito sa number 2, kailangan nyo lang computein to. Pag na-compute nyo itong maximum range na to, ipa-plus nyo lang sa 150. This will be the answer. Sa number 1, 2,386.37 meters. And sa number 2 is 562.84 meters. So, yun lang. Sana may natutunan kayo sa projectile motion. So, napakadali lang.
Ang galing! Ang galing!
So, paano natapos yung video? Thank you. God bless.